We're going to continue looking at the different types of contextual problems that you can get, with today focusing on increasing, decreasing. So as always, we're looking at exponential functions. I'm going to go where it says exponential formulas. And we know that our exponential equation is y equals abx. A meaning my initial value, b meaning my growth or decay factor, and x meaning time. In the previous video, we looked at how we can manipulate questions that ask about different kinds of times, periods of times. Right now, we're going to take a look at how can we manipulate the growth factor in order to answer any kind of question that they may give. So focusing on questions that deal with increasing or decreasing. So increasing should be growth and decreasing would be decay. But please note, increasing on its own could be linear, decreasing on its own could be linear as well. However, just how the question is worded will let you know whether it's exponential or linear. So before we begin, we're going to take a look at how they may ask you this type of contextual problems. There's two types. Okay, so there's one that has a rate. And what is a rate? A rate describes how fast something is increasing or decreasing, but it's usually as a percent per unit of time. Now, this is very, very important. If it is a percent, it must be converted by dividing by 100. The other question they could give you is not a percent question, but either a fraction or decimal. This does not need to be converted. So if they give you a rate, which means it's a percent, you do need to convert it by dividing by 100. So we're going to take a look at both examples. This will deal with percent. This will deal with fractions and decimals. So before we begin, it's very important for you to know the equivalence of each thing. So if I'm given a fraction 1/4, if I need to convert that into a decimal, I simply I do 1 divided by 4, which gives me 0.25. If I want to make that into a percent, that is 25%. And what do? I take my decimal and I multiply it by 100. Okay, or I can take my fraction and I can multiply by 100. Both will give me that percent value. So 1/4 is the same as saying 25 cents or 0.25, which is the same as saying 25%. Now, if I'm given, which is what's going to happen in our next problems, I'm given a percent and I know that a percent must be converted. How do I go from 50 into a decimal? Well, just think about it. How do I go from a decimal into percent? I multiply by 100. So to go from percent back into a decimal, I'll do the opposite of that, which would be divide by 100. So if I'm at 50%, I would need to divide it by 100, and that would give me a decimal of 0.5. If I have a decimal, how would I turn that into a fraction? I can click this fraction bar, and that will be 1/2. So go ahead and pause the video. What I want you to do is complete all these empty boxes so I can make sure that you truly understand the difference between the three equivalent forms. Okay, now that you know that, we are going to answer a couple of questions. So I'm going to start with this one right here. A tablet is purchased for $800. And as always, we know that our exponential equation is y equals abx. So I'm going to go ahead and start with that. Y equals a parentheses, or you could write multiply. In fact, last time I did parentheses, so I'm going to do multiply. So if I do shift 8, or you can come down here and click the multiplication button, and then b to the power of x, which is time. So this, my growth or decay factor is b, and then x is time. A tablet is purchased for 800. So again, just starting off what I think, it's purchased for 800. That is my beginning, my initial. So 800 goes with A. The tablet loses 40%. So if it's losing, I know that it's decay. So I know that 40 goes in here. I just don't know how. So that's what we are going to discover today. All right. So it's losing 40% each year. So at time 0, when that time has passed, I purchased it for $800. Okay. And then on the next year, it's going to use 40% of that. So if I say 40% of, and you see how the calculator is already doing it, 800. So I'm going to write that in my notes here. So if I have 40% of 800, I'm going to get $320. Now, think about what that is. I've lost that. So I've lost 320. If you notice in the table here, it talks about value. It doesn't talk about what I've lost. How much is this tablet valued at the end of this 1 year? So it's not valued at 320. It's what I lost. So to find that amount, I would say, well, 800 minus 320 would give me 480. So it is now worth $480. So when I'm trying to find the value in year 2, it's going to lose another 40% of its value each year. So now I'm going to find 40% of 480. 40% of 480, which is going to give me 40% of 480, which is going to give me 192. So remember, this is how much it is losing, not how much it's worth. So now if I want to find what is it worth in year 2, I'm going to take what is it worth in year 1, which is $480, and then I'm going to subtract the 40% which it lost, which equates to $192. So I'm going to have on the end of year 2, it is worth $288. And I'm just going to repeat this process. So if I want to find out what is its value in year 3, I'm going to find 40% of what it's currently worth, which is $288. And that's going to be $115.20. And if I want to find out what is its value in year 3, I'm going to take the 288 that it's worth in year 2, subtract the 40% that I just found out, which is 115.2. So now that tablet is worth $172.8. There's got to be a faster way of doing this. I can't keep doing 40% of each thing and doing this calculation, and there is. So we need to come out with what it is. So I want to find out, given any time, if I'm given 10 years, would I be able to find this value without having to do 40% of the previous year each time? All right, so let's go back to what we started this unit talking about. How can I tell from B if the function is either growth or decay? So I have a table. How can I find out what my B value is from this table? Well, if you remember, you are trying to say, well, what am I multiplying each time to get my next factor? And to find that out, the easiest way is to take your second value divided by the first value. So my second value is $480, and I divided by my first one, which is 800. I'm going to type that right up into the calculator. I'm just going to get rid of all of that. All right, so 480 divided by 800 is going to give me 0.6. So my growth or decay factor is 0.6. And the question is, how can I tell from this number here if it is growing or it's decaying? Well, I know it's 0.6, which means it is decay. Why? Because the factor is less than 1, but greater than 0. So it's between 0 and 1. If it's growth, remember, it's going to be greater than 1. So B would be greater than 1. So I know that this is decay, and that makes sense because it's losing 40%. Okay, so 0.6. So normally what I would think then is that 0.6 goes in here. All right, so let's check that. Let's think about that for a second. If I make this a table, it should match my table. 0 is 800, good so far. 1 is 480, good so far. 2 is 288, good so far. 3 is 172.8, so this is great. This is my decay factor. Now here's my question for you. How would I go from the question, because I got the 800 here, how do I get this 0.6 straight from the question? Because I've used the 800, so now I have loses 40%, somehow has to become 0.6. So I want you to pause the video and I just want you to think about it. If I was going straight from the contextual problem without having to do all this work that took me way too long, what kind of shortcut formula can I come up with that says everything stays the same, but B changes somehow so that I can get it right out the question? So what I'm saying is Y is equal to A, and then B is somehow going to change, and then you're going to have time, which is X. So what can I come up with to put here that will work for any situation based on the only other number, which is it loses 40%? What can I come up with to write as a general formula here that will basically make my growth factor 0.6? So how can I go from 40% to 0.6? So pause the video, just give it a shot, see if you can come up with it. All right, so well, I do know from our beginning, going from a percent into a decimal, all I would need to do is divide it by 100, right? So let's go ahead and do that. So I have 40% divided by 100, because now it's a decimal, we can compare apples to apples. So this is going to be 0.4. So now my question goes, how can I go from 0.4 to 0.6? Because that's what I'm looking for. So if you see, if I do, because it's decay, if I go 1, decay means I become less, and then I go with 0.4, you notice that I get 0.6. The question would be, would this work for every single time value. So we're going to put that in our B. So remember, we already know it's 800. And now we're saying our B is, and I do have to put parentheses for this actually, because if I start doing order of operations, I do need it in parentheses. So 1 minus 0.4. And we're going to check if this is going to work and give us the same table. So if I click table, does it match my table exactly? Yes. So far it does. So what it means is if I have a decay problem, all I have to do is 1 minus the decimal version. So if I didn't have a decimal version, how did I make it into a decimal? I divided by 100. So really what I have to do is 1 minus whatever the percent is divided by 100. And again, I'm just going to double check to make sure that this formula I'm coming up with makes sense. It does. It matches exactly. So writing the formula out, if we have a decay problem, it's going to be 1 minus percent over 100. Okay, so for decay only, it's going to be 1 minus percent over 100. Now we're going to check this out to make sure it works. Let's assume we have the exact same table and I don't want to do all of this work. So I'm going to go y equals, and I'm trying to answer this question. A tablet is purchased for 800. I know that's my beginning, so that's 800. All right, the tablet loses 40% of its value every year. So the word loses tells me it's decay. So I'm going to do 1 minus the percent, which is 40, divided by 100, because I need to convert the percent, and then to the power of x. And does that match what I have? Yes, it does. Okay, so once I type that in, that's my general formula. Now I can answer any question. So it says check a question, show a formula with decimals to see that it works. So we check that each time. So we're good. Find v when t is 10, and what does this value of v mean? Okay, so I'm going to make it a table. Find v when t is 10. So my time needs to be 10. So that is what v is, and it doesn't tell me how to round. So I guess I'll just round to the nearest. And let me just go ahead and do this. Round the number. So you're going to copy this number, Control C, Control V, comma. And I'm just going to round to, is this money? What is this? It is money. So actually, it doesn't tell me how to round because you know how many decimals is usually after money. For example, if I had $10.21, right? How many numbers are after the decimal place? 2, which means they're not telling you how to round, but they're thinking you are going to know that it's money, therefore you need to have 2. So this is $4.84. So if I'm going to write this in function notation, it's going to be v is the name of our function, time is 10, and it's going to be equal to $4.84. And I'm going to explain what this means in the context of the problem. So this is a tablet that is worth $4.84 after time, which is going to be each year. So after 10 years have passed. So this is going to say after 10 years have passed, the tablet is worth or is valued, the tablet is valued, or you can say worth, doesn't matter, at $4.84. Okay, now that you know that, and this is strictly for decay, how would you write the shortcut formula for growth? So remember, decay is going down and growth is doing what? Going up. So it's very similar to the decay formula, only now instead of going down, it's going up. So again, remember the only thing that's changing is our B. All right, so pause the video real quick and see if you can complete that for growth. So I'm hoping that you said if I needed to grow for decay, for it to go down, it's subtract. So of course, for it to go up, it'll be addition. So percent over 100. Perfect. That is if you have percent in the problem. What if you don't have percent in the problem, but the question is still saying, hey, it's increasing or decreasing by a certain factor. Okay, so again, it's increasing or decreasing by a percent. Fine, we now know how to do it. But what if it doesn't say increasing or decreasing by a percent? So for example, a house costs 120,000. It gains means increasing, right? Same as by increasing. So I should see 1 plus, and this time I have a fraction. Well, remember the only thing that has to be converted is percent by dividing by 100. If you have a fraction or a decimal, it does not need to be converted. So this is going to be 1 plus 1 over 10. And the same thing is if you have a decimal, this is not a decimal. But if you had 0.1, you would just say 1 plus 0.1. You just literally just typing in what it is. The only thing that needs to be converted is percent. So go ahead and do example 2 and 3, and let's see how you do on those. Let's practice.